Okay, so back in TrueView Evo, if you boot up, we'll do import Evo Cycle into new project. Or if you're already up, just hit the green arrow and get going that way. So I'm gonna do, we're gonna start on the first flight. We're gonna do import only. Next, select the import cycle. So it should be 1934. And I'm going to make an output folder. So and just like yesterday, be sure to try to keep your path link short, no special characters. Just like yesterday, we're going to select, you should have Alabama East already in your dropdown. If I can find it. Yeah, Alabama East ellipsoid. The base station will already load right there. We're going to go 0.0 for the antenna height. Survey nail's already in there. Just drop down and grab that and finish and confirm. All right, so I'm going to go ahead and go auto create flight lines. And I just want those 3, so I'm going to delete this guy right here. And then we'll go on to create TrueView Trajectories. And over here, import. And get that in the root folder of what you downloaded. It should be flight1.postprocess traj. Mine's in a different place, so don't pay attention to.
What was the folder called that the strategy file?
Here, I'll show you on the data stick. So it'll be in the March TrueView training, and then just right there in the folder.
Okay.
Yeah.
The first one then?
Yeah. And on this again, let's starting flight number, I'll just do 1000 and create trajectories, confirm. And if it gives you that pop-up that X amount of photos are excluded because of trajectory, then just confirm and hit yes. So next step, we're just going to Geocode Lidar. I think I'm going to use the same settings as yesterday, min 35, max 75. We'll go ahead and colorize at this point too. I'll just go ahead and run that. Okay. Everybody got flight 1 done yet? Still going? Okay. Okay, I'll let everybody catch up to flight 1 and then we'll move forward together. I'll go ahead and start stepping through flight 2 and we'll get everybody caught up.
What was the flight altitude yesterday?
The flight altitude, 60 meters. Yeah. All right. So to import flight 2, we're just going to hit the green down arrow again. Same process, import only. Next. Grab the second one, which will be 1950. Won't have to change anything here. Base is in there. Antenna height 0.0. Next, select our Triana permanent base nail and finish and confirm import. Now when this second flight imports, I make this mistake constantly, but be sure to drop down this menu right here and select the 1950 flight. Otherwise, you might overwrite something you just did on flight 1 and mess yourself up. So I'm on flight 2, 1950. I'm going to go over to auto create flight lines. Those values are acceptable. Compute flight lines. There's my 4 flight lines in blue. That looks good. Now I'll go over to create TrueView Trajectories.
What was the length that you did for the?
That was 135 on this one.
Even for the shorter flight lines?
Yeah. And on this again, we'll just want to import and do the flight 2 post-process traj. Starting flight line number, I'll do 2000 this time. All the other values can remain. Create trajectories. Yeah, the colorization, it can take a little while depending upon your disk speed and GPU speed and stuff, so. All right, and then when the create trajectories is done for flight 2, I'm gonna go back over to Geocode Lidar. Same values are acceptable for this one, and go ahead and run that. All right, so I got my second flight here, geocoded and colorized.
Yeah, I have that on my screen too, but I don't see the first 3 flight lines anymore.
Yeah, they'll disappear. You know, they're still there. They just get turned off when you go to another flight.
Oh, okay.
Yeah, and actually, once you get all this done, really, you just want to go ahead and turn off all these vector layers. Okay, so now that we got our 2 flights, you should have 2 items here in your table of contents with the different timestamps. So now we just, now the steps that we want to go to is we're going to strip align this or merge it if you want to. And then what we're going to do is we'll pull in the control points and look at the vertical accuracy. I actually already processed this earlier and saw it's got a little bit of a bias, so we'll debias that to show you that workflow. So let's go ahead and run the StripAlign for Evo tool right here. And again, you'll need to be logged into the Reckon. So make sure that your login's active there on the upper right-hand corner. Otherwise, the StripAlign won't work.
You check both flights?
Yes. Uh-huh. And I'm just going to call this LAS aligned. Yeah. And then once you've submitted it, you can open your job manager and track the progress right there. If you don't have StripAlign for your setup or just don't want to use it, just control click both of these and right click and do merge LAS layers. Yeah. Yeah, I would just be sure to log into the TrueView training one. We'll have the authorization for it. So mine finished. You can see it says process ended right there. When that happens, just hit post process, and that's going to add it to your table of contents.
Where do you hit post process?
Yeah, right here.
Okay.
And now you can see I've got the LAS aligned in my table of contents. And just be sure to select that as your active LAS layer right here. I'm going to change mine to 10 view. All right, so now that that's done, let's go ahead and move into our doing our control points again like we did yesterday. Yesterday we did that import ASCII XYZ for the CSV file, but because we've already created that shapefile, we can load it that way now. So go to your add data button right up here, red plus sign with the little 3 green sheets. And we want to go to feature and green plus sign. Let's see, mine's in a different place, so don't pay too much attention to where I'm going. And you want to find this right here, the 210518 Triana.shp. And when you load those, you should see them again pop up here on top of your data set. Just like yesterday, let's give them a nice bold contrasting symbol and color. So I like red 8. And normally, like, really the best position strategy for checkpoints is you want them evenly distributed across your site. These are kind of all clumped up in the middle because we don't own this land under there and it gets plowed constantly. So once you have the checkpoints loaded like this, just like yesterday, let's go to the control points toolbar up here and select that. And then go over to the little spreadsheet icon there to open up our control report. We're going to want to change the method to inverse distance weighted, 1.5 radius map units, and calculate DZ. And if you get that all done, you'll notice that for yesterday's data set, we've got a RMSE. Well, actually, let me check. Okay, making sure I removed those ones from yesterday. We got an RMSE of 5 centimeters, which is right at the rating of the instrument. But we also have a mean error of about 4.8 centimeters. Which means that there's sort of a systematic bias in the GNSS signal that day. All right, so this is a good training data set to show off sort of debiasing. So you can see that our mean error here is about 4.8 centimeters, negative 4.8 centimeters. I'm not going to get into the statistics of how this works, but if your SDOM or your standard deviation of your mean is a very small value and nowhere near close to your mean error, then that means that there's a consistency of that bias. You know, they're all like, can be averaged down to about 4.8 centimeters. So because of that, you can justify debiasing this data set. So what we can do is we can drop the whole point cloud by 4.8 centimeters and it'll line up a little better. This isn't always necessary. You don't have to do it, but it can improve the accuracy of your data set slightly. So we're going to go into that next. I'm going to write that down just so I don't forget. Negative 0.48. Okay, so I'm going to go ahead and close that. And so what we're going to do now is we're going to kind of move into doing point cloud tasks, which are sort of a whole set of analysis tools that Evo has for altering and examining data sets and whatnot. So let's, over here on your table of contents, you see how there's a point cloud task tab? Go ahead and click on that. And then on the upper right-hand corner, you can see there's like a little gear icon. This is the point cloud task manager. Go ahead and click on that. And this is where we can build our own custom point cloud task. One way I like to think about point cloud task is, you know, they're not so much like tools you're used to in you know, CAD or GIS where you've just got a set tool that you just run. It's a set of smaller tools that you can make presets for and configure together and make macros for and stuff like that. So it's kind of important to learn how to do this stuff. So what we're going to do here in the Point Cloud Task Manager is go to this Add button right here and drop down your task type. And we want to go for this Affine Transform LAS tool. And let's give it a name like Training Debias Z. This will make sense in a minute. Just go with me for a second. All right, and once that's done, hit OK on that. And hit OK on your Point Cloud Task Manager. And if it doesn't pop up already, you can see you can hit this drop-down menu right here and just find it. You'll have a lot less tasks than me. I've got a bunch of stuff I've done. And this is a very powerful point cloud task. You can see that it's got options in here for doing rotate, scale, and transform. So this is also the same tool that you would use if you ever want to translate your data set to a local coordinate system. You would, you know, use a scale factor or translate. So what we're going to do here on this one is let's see. We'll keep it simple for this one right now, but we will be using these point cloud tasks all day. Let's go ahead and click on rotate, scale, and transform. And then click on translate, and on the Z value, we want to put in that mean error that we had. So I'm putting in negative 0.48, or 0.048.
What was that under translate and you went under the Z?
Mm-hmm.
Wasn't it?
Yeah, correct. And then we're going to want to specify an output location for that. So if we scroll down a little more, you can see there's a option for output data sets, output folder. So we want to click this little ellipsis right here and open this up. And this will open up our IO manager, input and output manager. We'll get into more detail with this here in a minute. But all we want to specify is where we're going to put this data set into, because debiasing a data set is what you would call a destructive edit. Like it's going to permanently alter your point cloud. And because of that reason, we want to create a new one so that we have the original unaltered one. So we want to specify an output location for it. And this is a good opportunity for me to show you an environmental variable that we have here. So if you click on this under Transform Output folder, File folder, click on that, and we have a button up here with these little brackets. Click that, and you'll see that it'll put in this variable here, LP360 project path. I'll explain that in just a second. But I'm also going to append to the end of that. I'll make a backslash and say LAS underscore debias. backslash. Everybody got it in? Okay. Once you got that put in, just go ahead and hit close. And let's hit apply right here. Anytime you make a change to a point cloud task, you need to hit apply to save the changes for it. And real quickly, let me show you about what that project path means. If you go to File and Project Settings, you'll notice right here on the second value, project path, it sets LP360 project path. And this will be within the output folder of what we specified when we started this project. And the reason why you use this variable here is because for every new project that you have, you don't want to have to type this path every single time. So the next time that you run this debias tool, you won't have to alter this field at all. You just punch in your value and run it. So it saves you a lot of time and removes human error from the equation. You can see that's the path to this project on my local machine. So yeah, everybody's will be different. If you got it set in, then what we're going to do next is on the right vertical toolbar here, this bottom part, these are all the tools that we have to execute point cloud tasks. We can execute them for the whole project. We can execute them by geometries that we draw. We can execute it by vector features that we specify. And we'll get into all that later. But for right now, we just want to hit this sort of red checkerboard pattern right here. And this is execute point cloud task for a project. So it's going to execute this point cloud task, which is saying we're going to shift the whole data set down 4.8 centimeters for the whole data set and create a new one. So go ahead and hit that red checkerboard and run it. It should be a fairly quick task. It's just a simple mathematical operation. And you can see my task took 18 seconds. When this finishes, go back over here to your table of contents, the TOC. And you'll notice that it should populate your TOC with a new data layer. It just gives it a generic name, which isn't very helpful, LAS layer 1. I always rename these. The naming convention that I like to use is I like to append my processing task across the name as it changes. So remember we did an alignment, so I'm going to call this LAS aligned dashed debiased. And then I'm going to drag it down to the bottom above this one. And then I'm going to turn off the old aligned.
Just drag and drop?
Yeah. You kind of have to drag it you kind of have to grab slightly off to the right of it, and then you could move it. And I'm going to change my active LAS layer to aligned and debiased. And I'm going to go ahead and set my view back to 10. So visually, this isn't going to look any different, but we're going to run the control report again and see what it did. Okay, so now that that's complete, let's open up our control report again. So back here on the control report toolbar, go ahead and hit that spreadsheet icon. And we're going to do the same thing that we just did 10 minutes ago. We're going to calculate the DZ.
Is the Z probe location the control X, Y, is that the same?
Yeah, that doesn't need to get altered.
Oh no, I have 0.002.
Yeah. Yeah, so your mean error should be, basically all zeros, or just something, just an incredibly small value, like millimeters. And now you'll notice that my RMSE is 1.1 centimeters. So that's the vertical accuracy of my data set now.
Which one?
This PowerPoint's actually a work in progress for me, so there's a few rough bits. But after completing this module, attendees will be able to build a library of customized point cloud tasks. We've already done the first one. Explain how the adaptive 10 algorithm works and identify the 3 main parameters to adjust and to improve results. That's the main topic for today. The adaptive 10 algorithm is sort of the semi-automated tool that we get ground classification from. We'll perform the automatic ground classification on a point cloud. We'll use the cleanup tool and edit the ground surface with other PCTs for interactive editing. We'll also demonstrate how to smooth a noisy data set to reduce fuzziness, or what you could statistically call peak-to-peak error on points with hard surfaces. Explain when and how to implement these strategies, be able to write a multi-step classification macro, and then demonstrate how to use the export wizard for various deliverables. And there's a few other topics that I'm going to touch on too. So the big topic for today really is the adaptive 10 algorithm. So the adaptive 10 algorithm is it's going to classify points as ground returns to the ASPRS class 2, which is the default class for grounds. It's going to start by creating a seed surface, which is a 10, based upon a seed sample distance that we define. It's going to then iterate upon this seed surface based upon the angle and distance. So I've got some visuals that kind of make a little bit more sense. So if you look at those black lines there, they're sort of superimposing a grid over our point. The red points are our point cloud. So we superimpose a grid over it, and then within each cell of that grid, we're going to pick the lowest point in each cell. And with that, we're making the assumption that that's ground. That's going to be our surface. We're making the assumption that it's ground. And then you can see with the blue lines, it sort of creates a triangulation network or a 10 surface from that. One problem that you can run into with this method is, let's just imagine here that this blue box is a building rooftop, like our office here. You can see that if you want to pick the lowest point of a point cloud, and that cell encompasses the area inside of a roof, the lowest point is the top of the roof, which is obviously erroneous. That's not good. So we'll look at strategies for getting around that next. Once you have this basic seed surface, you're going to run iterations of this algorithm. So what it's going to do is, let's just say, for example, we've got 1,000,000 points and we create a seed surface that's got 1,000 points. It's going to take all those 1,000 points and compare them mathematically by distance and angle to the other 1,000,000 points and decide yay or nay if they match or not, depending upon those parameters. And it's going to, if it says yay, then it's going to add that to your new ground surface. And it's going to repeat this process in as many iterations that you specify. We usually do it 2 or 3 times. That's up to you. Yeah. And another thing to keep in mind about this process is LiDAR returns. I kind of touched upon this a little bit yesterday. So as a beam goes towards the ground, it could interact with other objects and cause multiple returns. These are usually canopy, limbs and branches and trees. It could also be power lines or any sort of vertical features that get in the way of the beam. And the reason why I mention this is because when we're trying to derive a ground classification, we only want last returns or only returns. Because if we have 4 returns, then the top 3, it's safe to assume that those aren't ground. Those are trees or some kind of other vertical feature. So when we run this tool, we're going to set a filter that's going to omit the early returns. We're going to set it to only single returns and last returns. Does that make sense? Yeah? Okay. All right. So, but before we do that, we actually want to, what we want to look at is we have a tool called smoothing that we can smooth data sets with and get much better results from our data set. One thing to keep in mind with the TrueView 515 and 435 is this is what's referred to by some people as a utility grade LiDAR or an automotive LiDAR. It was never built with the intention of being a mapping instrument. They're actually built for self-driving cars, and they've been repurposed for mapping. And for that reason, they have a higher noise window than other sensors that are made for mapping, such as the Regal or 600 series. So because they have a higher noise window, we can run this smoothing tool, and it will just sort of compress down surfaces. And what that will do is it'll make the adaptive 10 algorithm just operate a little better. So we're going to look at smoothing right now before we actually move into the ground classification. And before we go into smoothing, I also want to show you another tool called Planar statistics. And it's just sort of a quantitative method that we can do to look at the before and after of this smoothing tool so that we can understand what our data set looks like before and after, and what this tool does and why you may or may not need it. And the reason why we want to do this quantitatively is because science, I guess. We could visually inspect something all day long, but you kind of want a numerical justification for what you're doing and to have a deeper understanding of what's going on. All right. And this is going to be another point cloud task that we're going to build. So, and you kind of might already notice, like, I'm going to zoom into our front parking lot here, and you can kind of see how this parking lot, it looks a little rough, you know, it looks a little bumpy and stuff. And let's go ahead and we'll take this opportunity to actually explore the user interface some. So let's grab this draw a profile line tool right here. And I'm going to draw a profile kind of down the open area of our parking lot out here. So drag it down like that and right click. And I'm going to do a 0.3 or 30 centimeter wide profile. And it'll open up the profile window here. And on the profile window, let's just kind of go over a few navigation options that we have. So if you hold the right mouse button, you can pan the view. You can pan it left, right, up or down. You can see the view update on the screen too. One thing you may notice is if you pan up or down, it kind of snaps back, which can get annoying when you're trying to work. So if you want to turn that off, this third icon right here, recenter Z, extent of profile, just turn that off, and now you can freely move the profile. Everybody got up to that point? Okay. So another option that we have too for navigating profile is if we hold the left mouse button and pull the mouse down or up, it will zoom. And again, you can see it update here in the map view. If this indicator isn't available for you or you just don't like it, there's an option right here for draw the profile box in 2D view. You can toggle that. You also see it's got a line that tracks your cursor. Everybody had a chance to kind of navigate. We got pan and zoom and all that good stuff. Okay, one thing I see off the bat real quick is the points are really tiny, so I'm going to increase those. I'm going to go back to my live view up here, yellow oil filter, and I'm going to change my point size to, I'm just going to do 3. So that's a little bigger, but not too bad. Now another thing that we want to do is, you notice that we've got these horizontal and vertical lines. These are called graticules. They're just sort of a scale reference to what you're looking at. But by default, they may not necessarily be in values that are useful to you. So if we want to change these, you can see that there's a button here. This is the 4th button, toggle graticules. You can just click it to turn them on and off. And also, if you just control click it, it'll open up an options panel for the graticules. And what we typically do, at least if we're working in metric units, is we like to have graticules that are 10 centimeters vertical and horizontal. So to apply that to both horizontal and vertical lines, we have this quick grid option. It should default to 0.1. If you just hit this button right here and then apply, you'll see that the graticules are now at 10 centimeter intervals. So that really just kind of gives you a scale reference of what you're looking at. Oh yeah, on profile also, I'm going to change this changes the colorization view in profile. I'm going to change mine to the first one, elevation. That's a bit more useful for what we're doing at the moment. Okay, so what we're going to look at now is let's go back to this profile. So the reason why we set up the profile in this way to look at it is, now that you can see we've got 10 centimeter graticules, you can see that the sort of peak-to-peak error or noise window of that flat parking lot is more than 10 centimeters. And that's because, like I said, we're using a car LiDAR. If this were a Regal, it would be half that noise window. So what we want to do is we want to quantify this. We actually want to get statistics on what the peak-to-peak error is and what the root mean square error is, which is really the accuracy of it. And we have a point cloud task for that. So let's go over to a point cloud task again, just like we did for debiasing. And hit the gear icon up there to launch our point cloud task manager. And hit add again. And we're going to drop down and we are looking for, let's see if I can find it, Planar statistics right there.
Which one?
Planar statistics. And we'll give it a name, like I'll call this training planar stats. And hit OK. And you should have it open up here on the left pane. Not much to alter here. We're just going to specify an output file, which will be a shape file. So hit this ellipsis right here. And just like on the last one, we're going to look for the planar statistics output geometry file folder. Click that, and then click the little brackets here to add our LP360 project path. And at the end of that, I'm just going to append a name. I'm going to call it planar_stats.shp. Everybody got this set up this way? Okay. If you got it set up, go ahead and hit close and then apply to apply these settings to the point cloud task. No, actually, yeah, good catch on that. Let's actually go back to that IO manager. We want the output mode to be append, actually. Because what we're going to do is we're going to run the planar stats tool, and then we're going to smooth, and then we're going to run it again. So we want to see the before and after values. So yeah, be sure that that's set to append.
Where do you set it to append?
Open up the IO manager and go to the output mode, drop down, and append. Okay, so now what we want to do is the last debias point cloud task that we ran, remember we did that for the whole project. On this one, we want to do a small statistical sample area. So back around the same area as that, you may need to resize your profile to make all these tools a little bit more visible. But the one that we're looking for is this one right here. Execute point cloud task by envelope, or another way of saying it is a rectangle. We also have a tool for Polygon if you want to make a more complex shape. But for today, we just want to do envelope. And what I'm going to do here in our parking lot area is I'm going to draw sort of a small box, but not too small. It's a statistical sample area. So I'm just going to left click in the area. You can see my cursor like that, and just make a small box like that and release the button. And you can see there should be a shape there now. And if you go over to table of contents, there'll be a new vector layer in there called planar stats or whatever you named it. And I'm going to right click on that and go to my feature analyst. And now we've got a bunch of statistics about what the point cloud looks like in that area. And the important values that we're going to be wanting to look at here is we're going to look at range. If you look at range, you can see that it's 16 centimeters. So that's the peak-to-peak error. So the highest point and the lowest point of that box that we drew, the difference between those was 16 centimeters. So that's what you would call your peak-to-peak error or your noise window. And that's what we're looking to reduce so we can get a better result from the ground classification filter. Another important value in here is you can see we've got standard deviations is about 2.4 centimeters. So the first standard deviation of any statistical sample is roughly 68% of those values. You know, that's the majority of the values. And that's also a way that accuracy is expressed in here. So you could say that this statistical sample had an accuracy of 2 centimeters, but a noise window of 16 centimeters. And again, a real sensor would have much better values than this, but also costs way more. Has everybody gotten to this point and understand what's going on? Okay. And this isn't just an academic exercise. Like if you ever have a data set that you're questionable about the quality of it, you can run this tool also to see what you get, you know. Yeah, because I mean, you know, if you compare that to the profile that we've got, you know, you see there's like a stray high point right there and a stray low point right there. But really, if you look at most of the points, fall into a very narrow band in the center right there. All right. So if everybody's done that and they kind of understand where we're going, we can move on to smooth this. Everybody ready for the next step? Okay. All right, so let's go back to point cloud task again in our tab over here. Point cloud task manager, gear icon, add, and we're going to make a new task. And this one is called smoothing point cloud. And I'll give this a name like training smoothing. And you should have a window looking something like this. And we're not really going to change anything on this. You should always leave the tiled files options checked. You always want tiled files. We're not going to mess with any input on this. We're really just concerned with the output. This is another destructive edit because it's going to compress noisy portions of our point cloud and permanently alter it. So let's hit this ellipsis right here. And on the smooth output folder, file folder, click that. Click your bracket to add the project path. And after that, I'm going to make a new folder called LAS Smoothed. And when that's done, just hit apply. And I'm actually going to close my profile for a second here so I can see my tool. So now I'm going to run the execute point cloud task for a project, our little red checkerboard, and hit yes to confirm. And it'll open up a processing window here. Depending upon the speed of your computer and the size of the data set, this could take, 10, 15, 20 minutes. This one will probably be very quickly. Notice how this one car right here has got a bunch of interpolation for it. So does this one. Willing to bet those are black cars or, darker colored cars. Okay, so my smoothing just finished, and I'm sure y'all's is done or about to finish. I'm going to go ahead and go back to my table of contents. And just like last time with the debiasing, I've got just a generic name up here, LAS Layer 1. I'm going to name mine to LAS-aligned-debiased-smoothed. Again, so that I know not just what steps have been performed to my data, but what order they were performed in as well. And I'm also going to go back to my active LAS layer and change it to that. And because it's a new data set, I'm going to go ahead and hit my 10 view again. Okay, so the whole purpose of this is so that we can look at the before and after settings and understand them. So if you look at my screen, you can see it looks quite a bit different now. And I'm going to toggle back to my original just so you can see the before and after. So that was the before smoothing. And this will be the after smoothing. So you can already see visually it's very much different. I'm going to go ahead and open my profile view too and have a look at this in profile just to visually see how it changed there.
You're all closer.
What's that?
Closer now, right?
Yeah. Yeah, so remember the Graticules are about 10 centimeters. So I'm going to go, that was my original, and then back to my smooth. So you can visually see what happened there. But we want to run our planar statistics again too and see how the value's updated so we can see how that was affected. So I'm going to go back to point cloud task. And let's hit the drop down and go back to our planar stats tool that we ran earlier. And because this is a statistical analysis, we want to use the exact same samples before and after so that we're not, corrupting our sample. So we're going to reuse this box again. And the way that we do that is, I'm going to pull my profile down a little bit. Actually, I'll just close it. This button right here, the sort of box with the green arrow next to it, it's called Execute Active Point Cloud Task Using a Feature Layer. And if you click on that, you'll have an option for Input Feature Layer. It may default to planar stats for you like mine did. You can also execute this using only selected features. So if you had multiple boxes and you only wanted one, you could do that. But we've only got one feature here. So what I'm just going to do is I'm going to hit Run on this now. It's going to work very quickly. And now I'm going to go back to my table of contents, back to planar stats, right click and go to Feature Analyst, And now we're going to look at the range again. So you can see the before was 16 centimeters, and the after is about 3 centimeters, rounded. So now we just sort of, understood visually and quantitatively what happened with this smoothing tool. And it's worth noting that this mostly compresses hard surfaces. Complex features like trees and power lines, it's not going to affect those much. It may compress grass some. Yeah, so this is what we're looking at. And this is the data set that we're going to move forward to with doing ground classification now. So everybody comfortable with everything we just did? Does that all make sense? Okay. All right, so next we'll move into the ground classification. So what we're going to do is, let's go back over to point cloud task again and hit our little gear icon to go to the point cloud task manager. And let's add a new one. And the task type for this one will be the very top one, Adaptive 10 Ground Filter. And I'm going to give this one a name. I'm going to call this one Adaptive 10 Seed Surface. We're actually going to break this task into two separate parts. The first one is going to be generating our seed surface. So I'm going to hit OK on that and hit OK on this. And this is one of the more complex point cloud tasks. You've got a lot of options to kind of talk about here and set properly. So the first thing that I'm going to do is I'm going to change my units to meters and make sure that this radio button right here is set to advanced. I think it defaults to standard, but we want to go over to advanced.
It seems I don't have all these options here on my...
If it's not, just be sure to drop down your point cloud tasks and grab the one that you just made. What we're going to want to do on this one is, these settings shouldn't change, but we should check them anyway. Notice here on the source points how it's got double brackets on it. Anytime you see that, that means that there's an active filter applied. And that's important to know because if you're ever trying to troubleshoot some kind of aberrant behavior that you're not understanding, you should always check to see if you've got a filter applied that you didn't mean to, or the incorrect filter, or you shouldn't have a filter. So I'm just going to click this source points and look at what kind of filter we've got on here. And if I look at it, you can see that the returns tab right here, notice that the icon is yellow, whereas the other ones are gray. When it's yellow like that, that means that there's an active filter applied on this. So it's important to recognize that. And on this returns tab, this sort of matrix view is not immediately intuitive, but what it's basically saying is if this button's clicked, then we are filtering by first returns. So anything that is a single return will be shown. This next one is for 2 returns. So the way this is set right now, we're going to get the second return of 2 returns, but we're going to admit the first return of 2 returns, and so on and so forth all the way down. The 515 sensor only has 2 or 3 returns, I think. Yeah, so I hit scan on this. If you ever want to calculate the numbers in your point cloud, it doesn't do it automatically just for performance reasons, but you can hit scan. And now I can see that I have 25 million points that are single return only. I have 8 million points that are first return of 2, and those will be omitted from the tool that we're about to use. And I've got 7 million points that are second return of 2, and that's what we want to keep. We do have presets for this setting, so if you see over here on this drop-down, there's options for first return only, all returns, or last returns is what it should default to. That's what we want to use. So you don't need to change anything on this, but it's just important to know what these options are. But one setting that we do want to apply is, let's go over to the classification tab. And on this one, currently all of our points are in the class 0, created but never classified class. But eventually as you iterate on your data set and you classify trees and buildings and high noise, low noise, various things, you're going to start getting points in different classes. And if you run your ground classification after that, you only ever want to use class 0 and 1 as your input. So what I'm going to do on here is we've got these 3 buttons here for toggle all classes on, toggle all classes off, and switch selection or invert. So what I'm going to do is I'm going to hit toggle all classes off, and then I'm manually going to click 0 and 1. And be sure that your filter settings over here is set to filter only, which means that only class 0 and 1 will be input into this tool to be evaluated as a ground class or not. So if you got all that set up that way, just go ahead and hit OK. And let's look at the destination class on the next one. So go ahead and click on destination class. And we're not going to change anything here, but it's worth just looking at to see what we got. So it should default to class 2 ground, which is what we want. You can see also here we've got options for different flags like key point, synthetic, and whatnot. We'll get into this stuff at a later time, but it's not necessary here. So you can just hit OK on this. And let's go through some of these other options. Units set to meters, advance. We do want to hit generate seed points on this one. For the seed sample distance, I like to use 3. Let's use 3 today. So that's 3 meters. And of course, these values for the values for all these are completely up to the user, and you should experiment with them and learn how they work and how they'll give you different results. So on the next one, node insertion parameters. This isn't going to apply for this tool. We can ignore this box for now. And on the very bottom box for iteration control, let's just change that to classify only seed points and hit apply. So at the current state, what this is going to do is it's going to create this, like what we saw in the PowerPoint. This grid is going to be 3 by 3 meters, and it's going to pick the lowest point within each of those cells. So let's go ahead and hit apply. And once you've got that set up, just go ahead and hit execute point cloud task per project and run that. And this should be a fairly quick tool. And once that completes, you can see that it actually superimposes a grid over here. We'll delete this in a second. It's not necessary for data. It's just sort of a, just a tool to help you see. All right, so what I'm going to do now is, did everybody get to this point? Does everybody's look like that? Okay. What I'm going to do now is I'm going to change my 10 surface. I'm going to change it back to points for a minute. And then also over here on this filter drop-down menu, I'm going to go ahead and change mine to ground. And what we're going to need to do then is come over to this white and red pyramid, force 100% resolution, and click that. And now if you kind of surf around a bit, you can see that we've got 1 point per cell. And that's the lowest point. I'm going to go ahead and go back over to the table of contents. And you can see you should have 2 shapefiles in here for block seeds and seed grid. I'm just going to control select those 2, right click and delete. We don't need those yet. And I'm going to go ahead and I should have showed you some of this navigation tools, but we do. If you look at this little globe one over here, this is a zoom to full extent. So if you click that at any time, it'll zoom back to your full map. I'm going to turn my control points off too. We don't need those at this point. So this is my seed surface in points. I'm going to change it back to 10 view to get a better view of what this looks like. And you can see that it pretty much penetrated the trees. We got a nice smooth surface here around the trees, but we also have some sort of, we got the rooftops and we have some sort of noise and garbage on the very periphery of the map. And I actually have a visualization to kind of explain what this is. Because what we want to do next is we want to do a seed surface quality evaluation. We want to clean up that seed surface so that we can then run iterations on it and get our final surface. So there's a few different techniques that you can use. You can use one or more of these however you want. One of the things that we can do is an elevation filter. So if I go back to that live view, I could set a filter that says only classify ground points that exist between 35 meters and 45 meters. And so I'll just have a narrow band within my data set that it'll evaluate from. That's one way to exclude a bunch of trees and noise and stuff. You definitely always want to be looking out for low noise. And I'll show you that in just a minute. Because if you've got low noise underneath your surface, it'll cause what we like to call holes to hell. You know, it's just a big depression in your surface that doesn't really exist. One way that you can get a better seed surface to start with, we could have done this prior to this, is go ahead and classify out buildings and cars and water bodies. You're not going to want those anyway, so if you go ahead and classify them out, they would be excluded from a ground surface. You can also execute this point cloud task with a boundary. So if we had a plat boundary of what this project area is, we could load that as a CAD file or a shape file, execute by that shape, and everything outside of it will not even be evaluated. You can also create different versions of your adaptive 10 ground algorithm. Like you could have one for a desert and one for a pine forest and one for suburban areas and whatnot, because they all have different types of requirements for how you want to evaluate them. And then finally, what you're going to want to do is just manually classify out erroneous seed points. And we will get into that. Here's sort of a visualization of potential problems that could happen. This is what I like to call kind of an edge effect, and we already saw that at the periphery of our data set. And basically, what's happening here is this example happens from the forward scan edge of the sensor, but it can also happen on the side scan edges of the sensor. If you look in here, we've got this is in Florida, so it's super flat. We got a flat land, here's the a road bed, and then over here we've got more vegetation for another forest over here. And you may notice we got one seed point that's popped up in the trees right there. That's obviously wrong. And the reason why it happened is because the sensor, you can see that the ground doesn't connect over here. The sensor lost energy because it was just out of range of the sensor at that point. So the lowest point in that cell grid was right there. And then when we run the iterations on with this tool, you can see that we got a beautiful ground surface here, but it also iterated on this weird little edge here and caused this little, what looks like starting to be a hill. But it's not a hill, it's erroneous. So these are the kind of things that you have to be mindful of when you're creating a ground surface. And if I go back to my map view, you can see that I'm going to draw a profile perpendicular to that, and you can see that's exactly what happened right there. So we want to get rid of that. So what I'm going to do is we'll go ahead and start looking at some manual classification tools. So up here in the profile, everybody go ahead and get a profile open and the way that mine does, because we're gonna work on this. So just draw a profile perpendicular to the edge here. It can be fairly, when you're classifying in a profile, you generally want somewhat of a wide profile width, just so that you're doing more work in larger volumes. So once you have this profile open, what I'm going to do here is, you can see we've got a bunch of tools here on the right, and this is classify points above line, classify points below line, classify points with a polygon, and then we have a small, medium, and large paintbrush, and then we have a destination right here. So destination, I generally put this in a class 1 for unclassified. You could make the assumption that these are trees, and you could put it to a vegetation class if you want to. I'm just going to go with class 1. And for this particular portion that we're looking at, the best tool for the job would be classify points above line. That's going to do the most work for you. And the way this tool works is, here in the profile, I'm going to left click an area, drag my cursor, and you can see that it starts to outline those points. And once I reach the end of the area I'm interested in, I will left click again, and then just hit the space bar to classify them out. So those points move from ground class to class 1. And you'll also notice that it updated my 10 up here on my map view. And you may also notice, see, I've got our rooftop over here on the right side. I could have classified that out prior, but it's a good exercise to use these manual classification tools. So I'm going to hit that rooftop as well. Again, left click an area, drag your cursor, outline them, left click again, and hit space bar. And once you do that, back in the profile view, if you use your mouse wheel to scroll up and down, you'll notice that it actually jogs through your profile up and down, or at least not up and down, but perpendicular to whatever area you're looking at. So here's some more noise that I need to get rid of. I'm just going to use I'll use the large paintbrush tool just to kind of show how that works. See how I've got a paintbrush tool here now? I can just left click and drag around and outline those points and hit left click. The paintbrush tool is a little bit better for doing more precise work. Usually using the above and below line tool, it gets the most work done for less clicks. So I'm just going to keep scrolling through my profile here and just kind of getting rid of these erroneous points. Get rid of rooftops, get rid of vegetation. One thing I kind of should have shown before this is I'm going to open up my live view and scan again, and we can actually get a count of what's happened here so far. Let's see what we got. So you can see I got about 8,000 ground points. That's my seed surface. And so far I've changed 93 points of noise so far. But let's just keep going through this data set and get it nice and cleaned up.
Yeah, it's still not updated.
If you ever have any questions about what, if you're like, I don't really know if this is a tree or ground or whatever, you can use the Image Explorer tool. So this left vertical tool, if you click on this, what will happen is you can click on an area and it will show you all of the matching photos for that area. So like you can see, I got a good example over here. So see, these two right here, these look like low noise that we need to get rid of, right? But actually, if I click on this right here, you can actually see that this is a drainage. Like there's an actual like culvert drainage there. So this isn't low noise, it's legit. But this one is low noise. Let me click on that. See, that's a car. So if you ever need to do a deep inspection, you can just use that tool. And if you wanted to go ahead and jump into that, if you'll notice right here in our parking lot, see there's a bunch of low noise there. Yeah, that's low noise underneath the cars, so that's got to go too. But you got to be careful about what you call low noise because, like I said, you got that culvert. Sometimes you can see tree tips and other things that are legitimate, surface features. I know this might seem slightly tedious, but what we're doing a little work on the front end, and it saves us a lot of work on the back end. Because if you have a poor quality ground surface, you're going to have to do a lot of cleanup later on to straighten it out, and that can be extremely labor intensive. Once you get to the point where you want to start classifying out low noise, you can use the classify points below line tool for the exact same thing. So you can see on this one I got what a probable low noise right here. So just going to draw over that, and same thing. All right, so that's my cleaned up seed surface. So if you get through everything, it should hopefully look something similar to that. Another neat tool that we can look at right now that we've got this seed surface going on too is we've got an option here for display contours. And this will go ahead and kind of give you a preview of what contours might look like for your site. If you hit the drop down, there's also an option for smooth contours. And if you control click that button, it will come up with options to set the contour interval. So it's a nice tool to get a feel for what your data set's going to look like. You can also find data problems with contours, like if you see, for instance, this stream right here. This has a nice continuity, except right there. See how there's sort of a break right there? So see, that's an obvious way to check for errors. Let me look in there and see what's going on. Yeah, I think it's fine. It's just kind of interpolating across it. It'll look different once we run our iterations. All right, so for the next step, let's go back over to our Point Cloud Task tab. Open up our Point Cloud Task Manager, and we're going to add a new Point Cloud task on this, and this is going to be an adaptive 10 ground filter as well. Again, we're splitting this process into two separate pieces. So I'm going to call this training adaptive 10 iterations.
This was the first one, adaptive 10 ground filter?
Yes, correct.
Iterations?
Yeah, training adaptive 10 iterations. And once you get that, you can just hit OK and OK. And we're going to need to review some more settings on this. This will be similar, but some very key differences than the last one. So I'm going to go ahead and hit source points again. And on this, let's see, I'm going to, for classification, hit toggle all classes off and turn 0 and 1 back on. And we want to check the returns tab again and make sure that it's like the previous one where we have last returns. I'm going to hit OK on that. I'm actually going to, let's go ahead and turn off this force 100% resolution for a minute. We're not going to need that here in a second. And let's click on destination class. And on this, we're going to use a destination class will be ground just like last time, but this time we're going to set the key points and put it to set just like this. And the reason why we're going to do this is because if we don't like the results of doing these iterations, we can create a filter that will filter ground points by key points and unclassify them. So it's basically an undo button that we're going to set up for ourselves. And that way, if we want to undo it, when we come back, that seed surface we just spent time cleaning up will be as it was. So it's a good time-saving hack, life hack. Just like the last one, let's be sure to set our units to meters on this one.
And you set a destination of ground again?
Yeah, ground with a key point set.
Okay.
Yeah. So we want advanced settings. On this one, you can set the seed sample distance to 3 again. It actually doesn't matter because we need to click on this button right here. Use existing destination points only. So what this is going, we're telling the tool that it's going to only evaluate those seed points that we had left over. On the next one, node insertion parameters, we want to use this box for use specified values for all iterations. I'm going to change my angular threshold to 1 degree and my maximum distance to 15 centimeters, 0.15. And these 1 degree and 15 centimeters, these are extremely conservative values. You can bump these numbers up if you want it to be more aggressive.
15 centimeters or 15 meters?
15 centimeters, so 0.15.
Okay.
Yeah.
Gotcha.
I mean, hang on, I said that wrong, didn't I? No, that's it, okay. Yeah, like I said, these are very conservative values. You could bump the angular threshold up to 2 degrees as much, and the maximum distance up to maybe 50 centimeters. But the more you increase that, the more likelihood that you're going to get of getting sort of erroneous points. Like the ground filter could climb up like mailbox posts and car tires and pieces of brush, grasses and stuff like that. So it's always a trade-off, you know. On this one, let's do a mid-edge climbing algorithm. This is supposed to be an algorithm that can sort of help it climb over train tracks and curbs and stuff like that. So if you're in a purely urban environment like a city, using that might be okay, but I've found when there's any kind of vegetation around, it could be more of a problem than it solves. So we're going to do a mid-edge climbing algorithm. And for perform iterations, I like to do 3. And this is another one of those values that can be more or less aggressive depending upon the value you set for it. You could set it up to like 10 or something and it'll probably start making a bunch of crap, you know. But 1 or 2 might be a little too less. So once you got all those settings in there, just hit apply and just verify that everything looks like this. And when you're ready to run it, just hit the execute point cloud task for a project to run it. And this is one of those tasks that, depending on data size and computer, it could take, I've seen it take as much as 10 minutes or something. But this is a fairly small data set. And you'll start to see your results come in. Keep in mind, too, that the original seed surface that we were working from was about 8,000 points-ish. So it'll be good to see what it updates to. I'm guessing this will probably be like, 10 million, 12 million, something like that. We'll see what happens. All right, so there's my finished surface after the iterations. You can see it basically looks the same, it's just got, vastly more detail. And also, if you had problems with noise, like around your edge or low noise, those might be a little bit more exaggerated now, so you'll definitely be able to pick those out. I'm gonna go ahead and open my live view and scan and see what the results come out to be. Yeah, so I went to about 20 million points. So we got 20 million ground points and roughly 22 million non-ground points. But the general thing that I like to think about with is you want this automatic ground classification to do like 95% of the work for you. And then we're going to go through with some manual cleanup tools and some manual editing to put the final polish on it. So at this point, what you want to do is you want to use some different visualizations and different inspections to kind of understand what your ground class looks like. A good way to look for problems is like, I don't know if y'all noticed that loading ramp that we had out front, but see how we have all this interpolation right here? That didn't get classified too well. It looks like we have some sort of like, see these little bumps right here? It looks like it might have climbed up a few tires. We could clean that up if we wanted to be really super detailed about it. It looks like this might be a low noise right here. And another way of inspect, there's also some interpolation here. Check out around that culvert right there. And then also over here around our building, you see a bunch of interpolation right here. This is a pretty steep slope leading up into those loading ramps. We also have this concrete curb right here that kind of got classified. We could clean that up if we want. So one thing that's important to keep in mind when you're doing this classification is, notice up here, I kind of pointed this out yesterday, this number right here, it says 100%. We're seeing all the points being rendered into a 10 right here. But if I zoom out, it goes to 7% or 14%. It's dynamic as you change scale for your map. So it's good to always be aware of that, because generally you want to kind of go down to 100% and just poke around in areas and see what's going on. Like here, this is a pretty deep ditch leading into a culvert, and we got some interpolation there. That might be worth looking at. This thing right here, this is a power transformer. You can see it's kind of, the ground's kind of creeped up on the side of it a little bit. It's probably not much of a big deal, but if you want to be detailed, we could clean that up. One thing to keep in mind with these kind of like minutia details with the ground classification is one of the steps we're going to do afterwards is thinning. So we are going to thin this data set down, and a lot of this super fine detail isn't worth getting super worked up about. But another view to look at, to look for problem areas, is I'm going to come up here to my colorization view right here, drop this down, and the third option is display by classification. And then I'm going to change my filter back to all points. This is actually a nice way, switching between these filters too is kind of a cool way of seeing your before and after too. So you can see that's what our full point cloud looks like before we did our work. And then if we go to ground, you can kind of flick back in between those and kind of get a feel for how much work you got done. But for the time being, I'm going to look at this particular view. We're going to look at display by classification, all points. And what we're looking for is we're looking for kind of, the ground is obviously this sort of yellowish brown, and unclassified is gray. So we want to look for big splotches of gray that are probably good ground, like around this loading dock. This needs to be touched up a little bit. Maybe around here too. And obviously this loading dock right here, that needs to be touched up. What else do we got? Maybe a little right there too. But it's just sort of a good way to get a broad overview of your data set and where the problem areas might be. That's actually pretty good. I mean, it looks like we've got, 3 to 5 spots to clean up depending upon how detailed we want to be. So what we're going to do next is we're going to build another point cloud task called the ground cleanup tool. And the ground cleanup tool is, it's the exact same algorithm that we were just looking at for the adaptive 10 algorithm. The only difference is we're going to manually place seeds for that one. Instead of having them generated, we're going to manually place the seeds using that tool. So again, let's go over to our point cloud task down here. And click right here on our point cloud task manager and add. And this time we want to look for the ground cleanup filter right here. And let's just give this a name. I'm going to call mine training ground cleanup filter. And hit OK. And OK. And hopefully it should pop up right here. And we'll go through these options in detail. This is very similar to the last one, but there's a few little tricky options in here that we want to pay close attention to. Let me actually pull up my previous one so I can have a good reference and not take us off course. The units that you choose for a point cloud task are completely independent of your project coordinate system. So you can use whatever you're comfortable with as long as you do the right conversions. So for the ground cleanup tool, let's just kind of go, these are the final settings that we're going to want to get to, and let's just go over these together. Let's start at the top with source points. And this should be completely identical to the last one. If it's not already set this way, go ahead and hit toggle all classes off and then turn on class 0 and 1. And we also want to go over to returns and make sure that we are set to last returns. And also verify that both of these filter tabs are yellow so that they're active. If one is not, be sure to click on filter only to make sure it's on. And we'll go to boundary seed points next. And on this one, we're going to want to only have ground clicked. So what you'll probably need to do is toggle all classes off and then select ground and filter only. Ensure that the oil filter up there is yellow. All right, if everybody's looks like that, just go ahead and hit OK. We will click the Use Existing Seeds button right there. And then let's go to Destination Class, and just like the last one, we're going to do classification number 2, ground, and set the key points to set. We want to have advanced settings on this one as well. The seed sample distance, it doesn't matter. It doesn't matter what value's in there, if it's grayed out or not. If it's a fresh task that you've made, this will be able to be filled out, or if you've reopened it like I have, it'll be grayed out. It doesn't matter. On the next one, let's go over to node insertion parameters and select the third option for use specified values for all iterations. And on this, we want to put in the same values we used last time, so 1 degree and 15 centimeters. And this doesn't have to match what we did last time. I'm using the same values just because it doesn't really matter. But if you have if you're in an environment that has like extremely steep slopes, you could bump those values up a little bit more if you wanted to. I'm going to use a MIT edge climbing algorithm on this one again. And on perform iterations, I will do 3. So matches the last settings that we had. And once all those are set, I'm just going to hit apply. Everybody got those values in and feel comfortable with all that? No questions? Okay. All right. So just hang tight for a minute. I'm gonna just visually go through this tool with you guys because there's one little tricky part of it that can hang you up sometimes. So I'm going to zoom into a problem area that I want to kind of work on. I'm going to come over here to this, this loading dock and this ramp right here. And this cleanup tool is one of the ones that you will execute with a geometry. I like to use the execute point cloud task by Polygon on this one. That way I can draw a very specific shape that I want. You know, for example, this one, I'm going to just go ahead and start left clicking and very crudely kind of outline this shape like this. It doesn't have to be super precise, just kind of encircle the shape that you want. And one thing to remember about this task is that it has an undo function, but it only goes up to 500,000 points. So you kind of want to do it in small chunks. That way you have that undo function available. And if you mess something up, it's not a huge waste of time. So once I've got the boundary that I want, I'll finalize that by doing a double left click. And you'll see that it's frozen on there. And a very important point at this point is look at the very bottom status bar. It says select one or more 3D points within the defined area. Double click to continue. And actually, I should have had my profile open. Let me go ahead and get that open if I can. And points. I'm going to change my profile to all points and classification. Now what I'm going to do in here is I'm just going to left click inside of this polygon, and this is how I'm going to place seeds. So watch if I just left click in there. Let me zoom out and get in there. you can see that yellow spot right there. I just planted a seed spot right in there. And of course, you know, this is sort of, you know, what they would call a priori knowledge of the area, where I know from being out there or from inspecting photographs or from somebody telling me that this is concrete. This is a flat concrete surface. It is good ground. So I'm just kind of clicking seed points in there. It's very important to watch this profile to where they're placed, because if you had light posts, like there's a light post over here, I wouldn't want to place a seed point on top of the light post or a tree, because that's not ground. So pay attention to your profile. You can also plant seeds in the profile there. Let me change this depth if I can and show that. So see, I can click directly in the profile right there and click on the ground. Now, with these seed points here, you don't have to go too crazy and do like 500 of them. The more important thing is to have an equal distribution. So you want to cover the whole area of it with a nice even distribution of points. So I'm just going to kind of go through there like this. Spread them out very good. Make sure that they're all actually on the ground. And when I'm happy with my seed points and their distribution, to apply the changes for this point cloud task, I'm just going to double click the final point and you'll watch it update. There we go. So it cleaned up the ground. Now I just did a bunch of yammering and talking through all that, but it can be done very quick too. So see, I'm just going to kind of go through this, double click that, kind of go through there. I'm going to avoid that light post. Hit a few points, double click it, and you can see it's a very fast tool as long as you're you know, paying attention and everything. And see, there's still a little bit of a sliver right there. I could rerun it right there and try to tighten that up even further if I wanted to. But that's basically how the cleanup tool works. Another use that the cleanup tool is very good for, this is a good trick, is let's look at this forested area over here. See how I've got a lot of trees here, and you can kind of see how it's kind of gray and blobby, that there's you know, ground that's not totally classified. Let me switch back to my ground class and look at that. See that interpolation right there? That's really fine, honestly. Like, once we thin this out, that's not going to matter. But if I wanted to clean this up a little bit, I could do the same thing. I'm just going to draw around this one. And then I'm going to come over to my profile, maybe make it a little thinner. If I didn't mention it already, this tool right here, modify our profile depth, you can change it right in there without having to totally redraw it. So now from inside this polygon, I can scroll my mouse wheel up and down, and I can just find good ground points. Actually, that was outside the polygon. There's a low point. See that guy right there? That needs to get cleaned up. That's what probably caused all of this, is a seed got planted there and it caused a hole in there. So I'm just going to sort of go through this and click what I perceive to be good ground, avoiding these trees above. I'm not going to go too crazy with this one. Let's see. I probably should have cleaned up that low point so it doesn't cause me more problems, but I'm just trying to illustrate that this vertical tool is very powerful if you're trying to work through vegetation. I'm going to double click the last one, and there we go. Let me switch back to ground and check my results. Ground, and yeah, there's a lot less interpolation there, so it kind of smoothed out that steep slope there. So yeah, just go ahead and start poking around with your data set and try to get rid of some of these gray blobs. Remember this loading ramp right here. And I'm actually going to look at some of these, like check this thing out. You know, this is, see that low noise that got missed? you can always get that after the fact if you want to. I'll just, actually we do have a class for low noise if you ever want to get rid of it, so. Got that, there we go, cleaned up that low noise. So, yeah, go ahead and take a stab at the ground cleanup tool and get used to that. Yeah, start with some very small areas just to kind of, work on your chops with it. So like I'll do a little small box right here. Draw on the polygon, double click to finish the polygon, and then left click inside of the polygon to place seeds. Or do them in the profile.
This one right here.
So the execute point cloud task for project is not applicable.
Yeah, no, you want to execute it by polygon. So move up a few tools and see this one.
And click that one.
Yeah, yeah, execute by polygon. Yeah, one thing that can be tricky about this cleanup tool is there's certain user interface elements that you can click that might cancel you out of this task. So once you start it, you just kind of need to, focus in on what you're doing and not click too many other elements of the program. That's why I like to do it in small chunks, because if you make some elaborate shape and spend a bunch of time making like 200 points and then click the wrong thing and exit out, you're gonna be a little mad. Something that might happen to you sometimes is check out what happened here. I've got a seed point that was placed up here in these power lines. When that does happen, you can, it's a little hard to hit that small point, but you can actually click it and drag it down. If you can hit it, it's kind of a small target to hit. Oh, it's right click, I'm sorry. Yeah, you right click and see I can drag that seed point up and down, and I'm just going to drag it back down to the ground where it should be. There isn't a way to undo a seed point after the fact. So once you place a seed point, you can move it up and down, but after you've clicked another one, then it's set. We will be implementing an undo feature for that at some point in the future.